Okay, a quick digression to talk about this notation. Well, frequently we have these sums, something like 1 squared plus 2 squared plus 3 squared plus 4 squared. And we want to summarize that in a nice compact form. So here's how we do it. We say, well, we have 4 terms, and we use I, a letter I called an index. So this is I equals 1 term, this is the I equals 2 term, this is the I equals 3 term, and you guessed it, this is the I equals 4 term. Now we're going to summarize this sum using the sigma. Sigma is, I can think of it as a Greek letter corresponding roughly to S. So S for sum. And we're going to go to summarize this. We're going to say, well, my sum here starts at I equals 1, and it ends at 4. So I put a 4 on top. Okay, so I equals 1 tells me 2 things. It tells me that my letter for my index is I, and that it starts at 1. And on top, I'm being told where to stop. And then what am I summing? Well, every time, what do I have? I got 4 squared, that's I squared, right? Every time is I squared that's being added. Okay, so we would much rather write this because it's a lot easier to write than this. Okay, 4 terms isn't a big deal, but if I had 44 terms, then this would be quite painful, wouldn't it? Okay, another example. You know, if I have summation I equals 3 to, let's say, 7 of, I don't know, sine of I. Okay, well that is starting at 3, ending at 7. And it's a sum. So you go sine of 3 plus sine of 4 plus sine of 5. This is tedious, but necessary. Plus sine of 7. So hopefully that example illuminates what the notation means. If I'm getting lazy over here, which is frequently the case, I will go sine of 3 plus ... 1, 2, skip a few, and then sine of 7 is my last term. Okay, so just to save some time is money. Okay, so this is a bit weird. Doesn't happen very often, but this kind of thing happens all the time. So in fact, so much so that we have proven a couple formulas, which are very useful. Where are they? Oh, here they are. So you should pause and copy these into your notes. Okay, so what am I saying here with sigma I? I'm saying, I'm just doing I, so I'm doing 1 plus 2 plus 3 plus ... and I'm stopping when I get to whatever n happens to be. Okay, the assumption here is that n is at least 1. Okay, here, we talked about this one above. Skip it. This one is just your cubes. You're doing the cubes here. You're doing 1 cubed plus 2 cubed plus 3 cubed plus ... plus n cubed. Okay, so these formulas are very useful. So what do I mean by useful? This is awful to write. This is better, more compact, but this rectangle is wonderful, right? Here with the sigma, I still have a sum. It's still complicated. It's hiding in the background, but it's complicated. But here, there's no more sum.